I'm Barbara Bernstein from BetterTeachingNow.com, and in this video we're going to go over how to use exponents and do mathematical manipulations with them. So what is an exponent? If I write 3 raised to the power of 4, that's a way of saying what that means. The 4 is called an exponent. And what this really is telling you, by definition, this means that you're going to take your 3 and multiply it by itself 4 times, the number of times in the exponent. 3 times 3 times 3 times 3, 4 times. I want to point out that it's a little bit like when we multiply. When we multiply 6 times 4, that means 6 added to itself 4 times. Right? This means 4 sets of 6, or you could also do it 6 sets of 4. You'll get the same answer either way. This is the base, the number that's on the line. This is kind of our line. The base multiplied by itself 4 times. So when we do this calculation, 3 times 3 is 9, and then 3 times 3 is 9 again. So it's the same thing as 9 times 9, which is 81. So an exponent is like a shorthand, just a short way of saying multiply the base by itself that many times. So now let's take a look at some problems. 2 to the 3rd. Think in your mind what that would be. The 3 is an exponent, so we're talking about 2 times 2 times 2. That was 3 2's multiplied by each other. 2 2's is 4, and 4 times 2 is 8, so this is equal to 8. Now, what about 2 times itself 5 times? That's what I've got here, 2 to the power of 5, or 2 with an exponent of 5. So let's check it out. 1, 2, 3, 4, 5. I've got 2 multiplied by itself 5 times. 2 times 2 is 4. This other 2 times 2 is 4. 4 times 4 is 16. And then I still have the last 2 over here to multiply. 16 times 2 is 32. Notice that I could do it grouping them this way and then have this in pairs. And then the last 2 would be by itself since it's an odd number of 2's that I'm multiplying. Or I could have done this. I could have said 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. That would be another way of grouping the factors to get the answer. It would be the same answer. It's just 2 different ways of doing it. Now, let's take a look at something a little more complicated. So 13 divided by 5 times 3 to the 2nd power. First, I want to just look at the expression that we're dividing by, 5 times 3 to the 2nd power. 5 times 3, it's also called squared. So when you have an exponent of 2, sometimes they use the word square, and when you have an exponent of 3, sometimes the word cube is used. Like if you said 2 to the 3rd, some people will call that 2 cubed. So we've got 5 times 3 squared, 3 times 3. Now I want you to notice that the exponent is referring just to the number next to it. It does not refer to the 5. So this is equal to 5 times 3 times 3. It is not equal to 5 times 3 times 5 times 3. If you see the difference, the square is not this is not the same, that means is not equal to this, because when we write a number like this, it's understood, unless there are parentheses telling you to do it differently, it's understood that only the 3 is raised to the second power. So this is 5 times 3 to the second power. This is the same thing as this. Okay, so what we have here is 13 divided by 5 times 3 squared. Now 3 squared is 3 times 3, which is 9. And 9 times 5 is what? 9 times 5 is 45. So this is equal to 13 divided by 45. How could I write that as a fraction? That would look like this, 13 divided by 45. We always, when we're reading a fraction down, this line means divided by. So it's 13 divided by 45. Okay, so that's what this is equal to. I want to make sure you can see what's on each line. So, okay, now let's take a look at this problem and see what that's equal to. 4 squared, or 4 times 4, or a new problem here. 4 squared plus 1 to the 5th minus 7 to the 3rd. All right, what's 4 squared? That means 4 times 4, and that's equal to 16, right? So this is 16 plus, now what's 1 times 1 times 1 times 1 times 1? I'm multiplying it by itself 5 times. It doesn't matter how many times you multiply 1 by itself, it's always going to be 1. So 1 to the 10th power, 1 to the 100th power is always going to be 1, because you're just multiplying 1 by itself a bunch of times. That always equals 1. Okay, and what about 7 to the 3rd? So 7 times 7 is 49, and I'm actually going to compute this out. 49 times 7, I always write things out. If you try and do things in your head, sometimes it's easier to make arithmetic mistakes. So I always don't trust myself. I write things out. This is 63, carry the 6. That's 28, and plus 6 is 34. So this is equal to 343. Okay? Now, 16 plus 1 is 17 minus 343. All right, so our answer is going to be a negative number. If you recall, when we talked about adding and subtracting positives and negatives, we said that whenever you have one thing and you're subtracting something else from it, it's equivalent to adding a negative of that second number. So minus, this is understood to be a positive because there's no sign, minus a positive is the same thing as plus a negative. Okay? Little tip, write negative signs big enough so you don't not notice them. If you go on and do something else and come back and finish up your problem, you want to make sure that you see that was a negative 343. If you do it like this, boop, it's a little easier to miss the negative sign. So you want to make sure your negative sign is big enough so you don't mistake it. All right, when we add a positive and a negative number, the operation we're doing is addition. When we're adding a positive, and I say positive because there's no sign. If there's no sign, it's understood to be positive. So I've got a positive 17 and a negative 343. When I add those numbers, I take the difference between the numbers, or I should say the difference between the absolute value of the numbers. So an absolute value is the number regardless of sign, just the number itself. So I've got this number, and I'm ignoring the fact that it's a negative. I've got this number, and I'm ignoring the fact that it's a positive. I want the difference between their absolute values. So that'll be, this is 7 from 13 is 6. Subtract the 4 and make it a 3. 1 from 3 is 2. Nothing from 3 is 3. So the difference is 326. The answer to this is 326, but I use the sign from the larger number. So it's negative 326. That's what this equals to. Negative 326. Okay, moving along. We've got x squared plus 2x squared, and what does that equal? Now I want to point out to you that although I don't know what the value of x is, in other words, I don't know if x is 3, x might be a tenth, x could be any kind of number. It could be a negative 6, it could be 0.01. X just represents some number. It could be any type of number, it doesn't matter. But I'm saying whatever x is, I'm squaring it, or I'm multiplying it by itself 2 times. Anytime you have a symbol like this, you can always put a 1 in front of it, because 1x squared is the same thing as x squared, because you're just essentially 1 of that means 1 times x squared. And if you multiply 1 by any number, you get that number. We haven't changed the value. And I think if you put a 1 in front of it, it becomes a little easier to see that you're saying 1 of these things called x squared plus 2 more of these things called x squared. That makes 3 of those things called x squared. So I didn't, in these cases, I've actually solved and figured out what number my expression was equal to. Here, I can't do that because I don't know the value of x. Now, if you tell me x is 3, I can go through and say 1 times 3 times 3 is 9. 1 times 9 is 9. 9 plus 2 times 9, that would be 18. It'd be 9 plus 18. I can give you an actual number for the answer. But if I don't know what x is equal to, all I can do is give you an expression. And what we say, we use this expression. We say, this is the answer in terms of x. So I had to include the x because I don't know what x is equal to, but this plus this is 3 x squareds. Okay? Now, in order to add them together, they have to be the same letter and raised to the same exponent. So down here, I've got, by letter I mean the base, the number on the bottom that is raised to an exponent. This is called the base. And you know, when you play an instrument, a bass, if you're familiar with an orchestra, has a deep sound. It's down low. Or the word basement in a house is the lower level. So that can help you remember that the letter or the symbol that's right on the line, down lower, that's the base. And the letter up higher, to the right of the base, that's what we call an exponent. Let me write that for you so you can know how it's spelled. It's exponent. Exponent. Okay. So this is y to the 3rd power, or with an exponent of 3. And this is y with an exponent of 2. Now this means, and we're going to see what we can say, this is what I call a plain number. There's no x's, no letters. It's just a number. This means y times y times y. And this term means y times y. Now they're different. And you could know that, like if suppose y is 2. This is 2 times 2 times 2, which is 8. And if y is 2, this is 2 times 2, which is 4. So they're going to be different. In fact, the only time they would have the same value is if y is 1, because then it doesn't matter what exponent you raise it to, it equals 1. But in this problem, the way it's stated, I don't know what the value of y is, and I can only give my answer in terms of y by leaving the y, the letters there. Now, to simplify this or to add these together, what would we do? I want you to think for a second, and I'm going to warn you, it's a little bit of a trick question, because I hate to trick people. So I'm giving you a warning. Okay, you've thought about it, right? The answer is that we cannot simplify this, because y to the third and y to the second are like different things, and I can't add them together. They're like apples and oranges. It's the exact same situation that we saw when we were trying to add what we call unlike fractions. And what I mean by that is fractions with a different denominator. If I wanted to add a fourth and a third, unless I alter how that's expressed and get a common denominator, I can't add these the way it's stated here. Because picture a pie, a fourth of the pie, or a third of the pie, they're different things. So you cannot add these directly. I don't have 2/4 and I don't have 2/3. Just like if I'm trying to add an apple and an orange, I don't have 2 apples and I don't have 2 oranges. They're different things, and I can't add them together directly. So these are also different things. They cannot be added directly, and a plain number with no y's is also a different thing. That cannot be added to the y's. So this cannot be simplified. This is the simplest form of this expression as long as I don't know what y equals to. Because if I know what y is equal to, I plug in the number and I can compute a final number that this equals. But as it's stated, I can't do that.